Hello, everyone. Again, this is part 7, I believe. Yeah, part 7 from President's Network. And this chapter cover interruptible activities. Interruptible activities are very important to learn. So we've talked in the previous lecture about how we look at the interruptible activities and how they work and the logic behind it. From here, we'll continue on. So for the interruptible activities, they have a restriction on early start. So this activity must start on day 0 to be able to finish the other activities that are dependent on at the specific time. From here, we can see that activity B is completely critical, but A has just the starting day is critical here. So then moving on, for another example, A here is completely critical and must start on this date and must finish on this date. From Gantt chart, this is what we have. But then for activity B, the early start and late start are flexible, but the early finish and late finish are restricted here. They must be, this activity must be done at day 10. The same goes for activity C. It must be done on day 10 as well. So from Gantt chart, we can see this. We have a flexible float here. It can start on this day or it cannot. It's up to the user, but they must be done all on these specific days. Yes, if you are wondering, this is unrealistic to have them all done on the same day, but just for the sake of the practice and this example and the concept behind the interruptible activities and their attributes, we kind of looking at this scenario here. Again, if there is no lag with finish relationship, then A is completely flexible, but B is completely critical, and C has its finish critical. So then B has to start and finish on these days. But for C, it must be done on the 17th, but it's flexible otherwise. So it could be, if you look at the duration, it's a 3, right? So you have all these days from day 0 to day 9. You can, you start the work, and if you don't want to, you don't have to. But then because you have 3 days, you must start on the 9 to be able to finish on 12. And also you can actually allocate your work, so you can have 1 day here, 1 day here, and the other day is the last one, but you're restricted to finish at that day. Now with lag, the same thing. So if we have A as a completely critical, then it must start and finish at those days. But for B, since it have 12 days, looking at the Gantt chart, you can wait 1 day. You don't have to start B, right? And then you start on day 1 and goes all the way to 12, but you have to finish on day 13. Also, it has a lag of 3 days. So B won't be able to finish until A is completely done. The same goes with C. So C is also restricted finish-wise, but also has all this time to work with. That doesn't have to start. And it has a lag of 1. So C won't be able to finish until B finishes, but it must be done on the 14th. So restricted float, we've talked about them already. Activity A has a critical start. We already mentioned that, right? It has to start on day 0 because B is dependent on A. So B can be start on 6 and finish at 11 due to lag. This is the way it should be done. But then C, it's flexible on its start and its finish. So start restricted float is the amount of time we can delay the rest of the work in an activity after it has started without delaying the entire project. This is an example where you have a start date restricted on day 0. You have 10 days as a duration with lag of 3. So after the 3rd day, excavation can start. So it can be done on the specified date, and that's what start restricted float means. The same thing here for finishes. So we talked about the restricted start. We also have restricted finish. So you're flexible with A. Yes, you have a duration of 10. But you are flexible. But B must start on the 0, day 0 with A, and then finishes out at 12. So C can finish out at 12 as well, which means we have also a restricted finish as well. So the finish restricted float is the amount of time we can delay the start of work of an activity or the rest of it. If it has started, then finish on time without delaying the entire project. And for example, here we have the landscaping and the driveway. So the driveway won't be able to finish until, the landscaping won't be able to finish until the driveway finishes, and so on and so forth. So this is kind of a glimpse from a schedule where you have exterior building, you have its start time finish date with its duration restricted, and the driveway is built, also restricted, but the landscape has to be done on the day 78 after the driveway finishes. Now, in typical scenarios, we may have a lag to it, just like an extra cushion to make sure the driveway is completely done, and then the landscape can be done with it. If you are pouring concrete, you need to give time for curing, right? Concrete curing. But just for the sake of the demonstration here, we have restricted the late finish of the landscaping on the day of 78. So our punch list can start on day 78 when we finish the landscaping, and so on and so forth. So this is kind of how we look at restricted flow to start and finish and complete an activity restricted in a schedule. And this is how we view them. Now imagine if we want to combine them in an overall schedule with determining the CPM. It'll be a nightmare for you if you don't pay attention to these details and seek the specification and what they're looking for. So with that, I'll stop here.